Greetings, my name is Eddie Kihara. I'll be the instructor for this course. So I'll officially welcome you to the SAT Prep course. This is Chapter 1, Basic Math. In this chapter, we'll be covering 7 lessons. 1, Simplifying Expression. Lesson 2, Solving Equations. Lesson 3, Proportions. Lesson 4, Plug and Chug. Lesson 5, Finding Volume. Lesson 6, Logic Word Problems. And last but not least, Answering Questions Given Charts. Note that you should download the PDF for this chapter by clicking on the message at the top right of your screen. And our website is eddify.co. Lesson 1, Simplifying Expressions. There are 13 questions on this lesson. Every question on the SAT is checking to see if you know a very specific skill. This question is no exception, and if you read, it's saying which of the following is equivalent to the expression above. Simply put, we are trying to see what's going to result when you subtract these two expressions. And only thing to be cautious about here is if you have a negative in front of a parenthesis, remember that it's not just floating there on its own. There's actually an invisible 1, which implies that we need to distribute this negative 1 all the way through every term into the second parenthesis. Since nothing changes on the first parenthesis, let's just copy it down. It's just going to be x squared y minus 3y squared plus 5x y squared. Now we have to distribute this negative 1, which makes all the signs in here the opposite. So the negative x squared y becomes a plus x squared y. The positive 3xy squared will now become a minus 3xy squared. And last but not least, the negative 3xy squared will become a plus 3y to the second. Next is combining like terms. Take a look and you see we have x squared y right here, and it's got another partner right here. So when you add these together, you'll end up with 2x squared y. Note that at this point you can eliminate choices A and B because they don't have the 2x squared y, and in doing so you will have improved your chances for getting this question right by 50% even before you complete it. Pretty cool. Next thing, we are going to be finding the next like term, which is negative 3y squared and the plus 3y squared, and negative 3 plus 3 will just end up canceling out. So those are gone. And last but not least, we've got 5xy squared minus 3xy squared, which ends up becoming plus 2xy to the second, which makes C our answer for this problem. Which of the following is the sum of the two polynomials shown above? Keyword here is sum, and all that means we're going to be doing some addition, adding two expressions. So there's actually two ways we could do this. So let me show you the first method. Let's call it method 1, and it's simply going to be an addition problem, one stacked on top of the other vertically. And I'm going to copy the second one down, 5x squared minus 2x minus 6. And since we are adding these, I'm going to put the plus sign. First things first, we've got 3x squared plus 5x squared makes it 8x squared. Next, we've got negative 5 plus negative 2. And let's write that off to the side just a little bit. Negative 5 plus negative 2. Remember, when you have a positive sign next to a negative sign, who wins that battle? It becomes a negative. So this really is negative 5 minus 2, which becomes a negative 7. So negative 7x. And last but not least, we've got the positive 2 plus negative 6. Once again, let's pull that off to the side. 2 plus negative 6. Once again, positive next to the negative. The negative wins this battle, so 2 minus 6, which is simply negative 4. So we end up with negative 4. That makes A our answer for this problem. Now, for the second method, let's go ahead and call it method 2. For those of you who may not like the vertical method, you're more than welcome to work this out horizontally. So we've got 3x squared minus 5x plus 2, and then you're adding to it 5x squared minus 2x minus 6, and of course combining like terms will be the next thing that we are doing. So 3x squared plus 5x squared makes it 8x squared. Then we've got negative 5x minus 2x, and that becomes negative 7x. And of course, last but not least, we've got positive 2 minus 6, which becomes a negative 4. And that, ladies and gentlemen, is the same answer as what we found originally. Same exact answer as that. So pick whichever one you like better. If the expression above is rewritten in the form ax squared plus bx plus c, where a, b, and c are constants, what is the value of b? This is another example of simplifying expressions, and all you would need to do is open up the second parenthesis, and we do that using the distributive property. And all that means is you're going to be taking this negative 2 on the outside and distributing it into each of the terms in here. Since nothing changes on the first parenthesis, let's just go ahead and copy it down. We've got negative 3x squared plus 5x minus 2. And now onto the distributing part. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x becomes positive 4x. And last, we've got negative 2 times negative 1, which makes it a positive 2. Next, we'll find like terms. And the first one is negative 3x squared minus 2x squared. That happens to be negative 5x to the second. Next, we've got 5x plus 4x. That becomes 9x. And last but not least, we've got negative 2 plus 2. Those, of course, cancel out, so we just go ahead and get rid of those. And our answer is this. The result is this. However, this question was asking us for the value of b. B, as you might notice, comes from the standard form of a quadratic equation. It is the term that is attached to the x value. So in our case, our b value is 9. Therefore, you would write 9 into the grid in sheet and make sure you shade the appropriate circles. Which of the following is equivalent to the expression above? Anytime you see quantities, that means binomials, trinomials, whatever it is inside of parentheses, if you have parentheses that are next to each other, like so, with things inside of them like 3 and 4, it implies multiplication. So all we're doing is just multiplying here. Now, let's go ahead and start multiplying this 3 into this first binomial, and we do that by distributing. So 3 times 2x becomes 6x, and 3 times 1 becomes 3. I'm going to enclose that in parentheses, and I'm just going to bring down the second part, which is 4x plus 1. And when you're multiplying two binomials, we have to FOIL. FOIL is just a mnemonic that stands for first, outer, inner, and last. And it just guides you on how to multiply. So let's go ahead and apply FOIL. That means first numbers multiplied. 6x times 4x becomes 24x squared. And next would be outer, which is 6x times the 1, the two outside terms. That becomes plus 6x. Then we'll do the inner terms, 3 times 4x. That becomes 12x. And last but not least, 3 times 1 is simply 3. The next step, as we've seen so far, is just combining like terms. So 6x plus 12x combines to become 18x plus 3. Now, bear in mind, we could have answered this question, or rather eliminated some of these answers early on when we started working it out. The moment we found 24x squared, we could have glanced at the answer choices and realized, hey, this doesn't have the 24x squared, and this one doesn't. Because this is such a time pressured test, it is wise to knock out the obviously wrong answers. And just as a time saving strategy, that's something you might want to do. You'll improve on that skill as we progress, but I just wanted to point it out here at this point so we can kind of start looking for it going forward. Which of the following is equivalent to the sum of the expressions a squared minus 1 and a plus 1? Keyword once again is sum, which means add. Therefore, we'll just go ahead and add the two expressions. So a squared minus 1 plus a plus 1. As usual, we'll look for like terms, and it appears as though we only have the negative 1 plus 1 as the two like terms. Therefore, we'll have a squared plus a as the result of this question, which makes a the answer to this problem. The expression above is equivalent to a over x plus 2 squared, where a is a positive constant and x cannot equal negative 2. What is the value of a? As with every other question that we've known on the SAT, this one is looking for a specific skill, and that skill is whether you know how to subtract fractions. To subtract fractions, remember we need a common denominator, so we're going to be looking for the least common denominator for these two denominators here. Well, since they're the same in that the quantities are x plus 2 in both of them, x plus 2 and x plus 2, the only difference is that one of them is squared, so the least common denominator is the bigger of them, so x plus 2 to the second power. Now what that means is we can go ahead and assign these one denominator, which is x plus 2 to the second power, and what we're going to be doing is looking to see if either of them is missing anything. Well, this one already has the x plus 2 squared, so we are not multiplying it by anything. However, the second fraction, this guy, is missing the second x plus 2. We just have the 1, so we have to multiply it by x plus 2 because we needed two of them. It only had one. So this is a really important aspect, so keep in mind that this 2 is not just sitting there on its own. This sign goes with this 2. So when we distribute, we are really distributing a negative 2. So negative 2 times x becomes negative 2x. Negative 2 times positive 2 becomes a negative 4. And of course, nothing changed here, so we'll just copy it down. 2x plus 6. And the next step is just combining like terms. We've got 2x minus 2x, and the answer to that is 0. So those just cross out. And next, we've got 6 minus 4, and the answer to that is simply 2 over x plus 2 raised to the second. Now remember, this question was asking us for the a value, which happens to be the numerator here. So our answer to this question is 2. And it's a free response question because there are no multiple choices. So enter 2 and gradient the appropriate circles. Which of the following is an equivalent form of quantity 1.5x minus 2.4 squared minus 5.2x squared minus 6.4? This is another classic example of simplifying expressions with the added complexity of squared. And all we need to do is square that. Now, let me point out one of the most common mistakes that students make is if you see something, for instance, x plus 3 raised to the second power, something like this, a binomial being squared, please resist the urge to say this is x squared plus 9. Please do not sort of distribute this squared in here. This is incorrect. That's a trap. Please avoid it. Instead, let's think about what do you do if you see, for instance, 3 to the second. To answer this, we typically say 3 times 3. And of course, the answer would be 9. So in our case, since we have 1.5x, this quantity here is squared, we're going to use this logic to open up those parentheses. So let's go for it. All right, so we're going to have 1.5x minus 2.4 squared. In fact, why don't we write this twice? 1.5x minus 2.4. Since we are squaring this, you have to multiply it to itself. Then I'm just going to copy the rest of it. Minus 5.2x squared minus 6.4. And now we just FOIL. Now remember, FOIL stands for first, outer, inner, last, and it's just a mnemonic that we use to help us remember how to multiply binomials. So 1.5x times 1.5x becomes 2.25x to the second. 1.5x times negative 2.4 becomes 3.6, negative 3.6 x, and negative 2.4 times 1.5x is yet another negative 3.6 x, and negative 2.4 times negative 2.4 becomes a positive 5.76. And now the second part of this, we want to be careful because this negative in front of this parenthesis is not. It's got an invisible 1 sitting right in front of it. So we have to account for that by distributing a negative 1 through here. Therefore, negative 1 times 5.2x squared becomes negative 5.2x to the second. And negative 1 times negative 6.4 becomes positive 6.4. The next step is just combining like terms. So we have 2.25x squared minus 5.2 squared, and that's simply going to be negative 2.95x to the second. Next, we'll deal with the x's. Negative 3.6x minus 3.6x becomes negative 7.2x. And by the way, notice at this point, you could eliminate 2 of these answers. Once again, A and B would be out. That leaves just C and D. And we'll complete this by figuring out the last piece, which is 5.76 plus 6.4. And the answer to that is 12.16, which makes C the correct answer to this question. On PS above, PQ equals RS. What is the length of line segment PS? This question is giving us a line segment with smaller parts. So we are told segment PQ is congruent to RS. So we can actually set this up as an equation. PQ is x minus 1. We can set that equal to RS, and that's 3x minus 7. And this would help us figure out what x is. Good news is, once we know what x is, we can then plug the x value here, here, and here, and work out each part to find the length of the whole line segment. We would need to add the 3 segments together. So PQ plus QR plus RS would give us the whole line, which is PS. And that's what we're trying to do. We're trying to work towards that. So let's go ahead and figure out what x is using the equation that we set up over here. To get x by itself, I'm going to start off by adding 1 to both sides. When you do that, the 1's are going to cancel. Therefore, x equals 3x minus 6. The next step is subtracting 3x from both sides, because like terms have to be on the same side. Therefore, what's going to happen, the 3x's are gone, and on the left, x minus 3x is negative 2x, and on the right side, we have negative 6. Next, we'll divide each side by negative 2, and that means our x value is positive 3. Now be careful, this is a free response question, and some students may be quick to fill in the answer or grid in 3 as the answer, thinking that they are done with the problem. Please do not do that. Make sure you read each question carefully. So we have to plug in this 3 back into every place where we have an x. So let's make this a 3 minus 1, so PQ is 2. And since we know that PQ and RS are equal, we can actually call this 2 as well. And of course, we just found what x is, so this is 3. If you added all the segments, you would have PQ is 2 plus QR, which is 3, plus RS, which is 2. Therefore, PS is actually 7. 2 plus 3 plus 2 is 7. Which of the following is equivalent to quantity A plus B over 2 squared? This is once again a question that is asking us to FOIL. The reason being, this is a squared. What that means is we have to write this twice, a plus b over 2 times itself, a plus b over 2. And foiling, once again, stands for first, outer, inner, last. First stands for the first numbers multiplied. A times a becomes a squared. The product of a times b over 2 becomes ab over 2. And the product of a times b over 2, once more, is ab over 2. And the product of b over 2 times b over 2 is simply b squared over 4. We look for like terms. These are like terms. We can combine them. Remember, there's an invisible one here and an invisible one here, which means we still have the a squared at the beginning. These combined become 2ab over 2. The reason why we could add these fractions so easily is because we already had a common denominator of 2 for each of them, so that helps. And of course, we'll just bring down the last piece, which is b squared over 4. That makes one of these our answers. But you may look, and when you glance over, you might notice that this doesn't appear. That's because we haven't simplified. Notice these 2's cancel out. So our final answer is a squared plus ab plus b squared over 4, which is D. Which expression is equivalent to quantity 2x squared minus 4, subtract quantity negative 3x squared plus 2x minus 7. Once again, subtracting polynomials. Only reminder here is this negative is never ever just sitting up on its own. There's an invisible 1 that needs to be distributed all the way through into the second parenthesis. And the shorter version of this, we'll just change all of these signs to the opposite. Since nothing changes on the first binomial, we'll just copy it exactly as is. So 2x squared minus 4. And we are changing all of these signs to the opposite sign as a result of the distributive property. So we'll have plus 3x squared minus 2x and plus 7. At this point, we just combine like terms. 2x squared plus 3x squared is simply 5x to the second. Then we've got this negative 2x that's just floating around on its own. So negative 2x. And last but not least, we've got a negative 4 plus 7, which is simply a positive 3, which makes A the answer to this question. Which of the following is equivalent to 3 quantity x plus 5 minus 6? This is a simple simplification question that we'll just go ahead and tackle. To open up these parentheses, we have to distribute this 3, and that results in a 3x plus 15 take away 6. And of course, like terms are 15 and 6. When you subtract those, the answer is 9. So just bring down to 3x. So our answer is C for this question. The expression above can be written in the form ay squared plus b, where a and b are constants. What is the value of a and b? So ay squared plus b is the format that we need to try and achieve from this expression. So we're going to take this and rewrite it to make it look like that. And once we do, we'll just read off the a value and the b value and add them together. Then we'll have our answer. So let's get to work. We've got the first binomial is 7,532 plus 100 y to the second. To open up the second part of this expression, we have to use the distributive property. So distribute that here and here. We'll have 100 y squared, because 10 times 10. And then 10 times negative 110 is negative 1,100. Next, we'll look for like terms. Of course, the 100y squared plus 100y squared is 200y squared. And for the other part, we have 7,532 minus 1,100, which results in 6,432. If you look closely, you'll now realize that, hey, you found your a value and you also found your b value, because that's what this form that we were given at the beginning said, that we would result with something that looks like ay squared plus b. And if you look, that's what this resulted in. Therefore, we'll just say 200 plus 6,432, and our answer is 6,632. Now remember, this is a free response question, so grade in your answer accordingly. Which of the following expressions is equivalent to the one above? Here we are continuing with the idea of opening up parentheses. So we need to distribute this negative 1 that's on the outside to open this second set of parentheses. Because nothing changes on the first one, we'll just copy it down as x squared minus 3. And we've got negative 1 times negative 3x squared is positive 3x squared. Negative 1 times positive 5 is negative 5. So we'll look for like terms. We have x squared and 3x squared added together. That's going to be 4x squared. Once again, keeping up with the trend, we can eliminate c and d because they don't have the 4x squared. Now we've improved our chances for getting this question right 50%. Next, we'll find the next like term, negative 3 minus 5. And if you recall from the previous slides, if the two signs are the same, simply add the numbers. Well, 3 is a negative and the 5 is a negative, so that's just going to be 8. And you always keep the sign of the bigger one, so negative 8. That makes our answer A. And that concludes lesson 1 in chapter 1 of our SAT prep course. So we can actually go ahead and put a check mark here. And let's just review in brief what we've talked about. So the first concept that I'd like to remind you of is we realize we can add and subtract polynomials. And the only thing you want to be careful about is the negative in front of the second parenthesis. For example, let's say we have x plus 3 minus x squared plus 5. This negative you have to watch out for because it means you need to distribute it. And what it does, it changes these signs to the opposite sign. So as a result, we would have x plus 3, because the first one doesn't change, minus x squared minus 5. Notice that the signs that were once positive in here are now opposite. The second idea was multiplying polynomials, specifically binomials. When you have something like x minus 3 and multiply that to x plus 5, we learned about foiling, which stands for first, outer, inner, last. That's taking the first term and distributing it to both of the terms in the other. and taking the second term and doing that same exact thing, and then just combining like terms. Third idea was adding fractions. You might call these complex fractions. An example of that would be when you had x over x minus 2 plus x, maybe 4x, over x minus 2 to the second power. We had to find the least common denominator, and we found out the least common denominator is basically what everything has to be represented. So in our case, it would be x minus 2 squared. And then once we do that, we add the two fractions, but before we do so, we have to make sure that we've multiplied this one by another x minus 2, because the LCD calls for two of them. This one only has one, so we have to multiply this by another x minus 2. Therefore, we would have x squared minus 2 plus 4x over our least common denominator, which is x minus 2 to the second power. Another idea that we should keep in mind is be mindful. Do not fall into the trap of distributing an exponent in here as shown. Please do not do that. Remember that a binomial squared means you're going to have to write it 2 times to multiply to itself and then FOIL. And kind of a mini lesson that we talked about, a mini review, was adding and subtracting integers. And we found out if integers have the same sign, like so, you simply add them and you keep the sign of the bigger. So 5 plus 3 is 8, and 5 is bigger, it's negative, so this would be negative 8. On the other hand, if the signs are different, let's say we have negative 7 plus maybe 4. When the signs are different, you simply subtract the numbers and you keep the sign of the larger. So 7 take away 4 is 3, and the bigger number is 7 happens to be negative, so that would be a negative 3.